Hello. So welcome to Tamali's classes. Today I'll be talking to you about ecosystem. This is not a regular class because today I will not talk to you about the entire topic of ecosystem. We will just do a quick revision of what is important for your exam. Okay. So class 12 students, are you ready? So let's start without wasting any time. So we'll be talking about let's take a note. Okay. So let's start. So first of all, we're talking about the ecosystem. Okay. So what is ecosystem? Basically, ecosystem is a type. It's a unit in nature where all the organisms they interact with each other and also with the physical environment. So that's a definition. Okay, that's what I told you. Definition. So number one, which is important out here, is that first let's talk about who coined it. A.G. Tansley. Okay, A.G. Tansley coined it in 1935. So components, you know what are the components of ecosystem? The components are abiotic and biotic. So abiotic is the non-living part and the biotic is the living part. So let's move on to the structure of ecosystem, which is very, very important for exam. So when we talk about structure of ecosystem, okay, so what's happening out here is that there are three types, okay. So one is the standing crop, okay, standing crop. Then we have the standing state, and number three, we have got the stratification. Okay, so let's talk about standing crop, which is very, very important for your exam. So standing crop out here means that the amount of living biomass, or its number of living organisms. So basically, when we talk about living organisms that are present in a unit area of ecosystem, then it's called as standing crop. And standing state is amount of inorganic nutrients. So this is what? This is living organisms, okay? Number of living organisms, NOLO. You can just remember this quick mnemonic, okay? Then we have a standing state is the amount of inorganic nutrients, okay. And number three is when we talk about the vertical layers. So if we talk about, suppose example, we talk about a forest vegetation where you can see the vegetation is very, very dense. So out there we have seen that you can divide this entire vegetation into 5 to 7 strata. Like we have got out here in the ground level, we have the grass. Then above that we have the herbs. Then we have shrub layer. Then understory trees, canopy trees, tall trees. So vertical layers, when we talk about that, is stratification. But here, what is most important is the standing crop. Remember this one, okay, for exam. Then coming to the functions. In functions, there are four functions, okay, four functions. So number one, we have got the productivity, and in this one, we have two types. One is the gross and one is the net, okay. This is very, very important, especially the net one is very important, okay. Net primary productivity, and this is the gross primary productivity. So what is the gross one out here? So okay, what is productive? Productive means the name itself says that is the rate of production. So that is the amount of organic matter or biomass that is accumulated per unit area in a unit time. Okay, remember the units. If we talk about weight, it's gram per meter square per year, and if we talk about energy, it's kilocalories per meter square per year. Okay, so in primary productivity, as I told, there are two types, the gross and the net. The gross is the amount of organic matter synthesized by producers per unit time and per unit area. Okay, and net is the amount of organic matter stored. Remember, so gross is the one which is synthesized. Okay, and net is which is the stored by producers. Okay, so gross is out here, amount of organic matter synthesized by producers per unit time, per unit area, and net is the same thing, but just not synthesized but stored by producers per unit area, per unit time, and per unit area. So this NPP you can write down. This you can write down as GPP minus R. Okay. So GPP, you know what it is? Gross primary productivity, and R is the energy used in respiration. As we know, when the respiration occurs, some energy is used in the process. So when we deduct that energy used in respiration, then we get the NPP on net primary productivity. Okay. So that means what? This NPP depends on GPP. Remember, NPP depends on GPP. as well as the amount of consumption of photosynthesis. That means how much it is being consumed matter, and then also the gross primary productivity. On both the things NPP depends. Fine. Now moving on to the secondary productivity. This is the primary one. Now the secondary one. So what is secondary one? Here this is the rate of resynthesis of organic matter by the consumers. So what does it depend on? It depends upon the loss while transferring energy containing organic matter from one trophic level, okay, to the next one, plus the consumption due to respiration and predation. Okay. So this is also important secondary one, but remember the primary ones, especially difference between NPP and GPP, and what is NPP, okay, the function, all these things. Now coming to the second function, that is the decomposition. So one is the productivity, same is decomposition. So decomposition means what? This is the physical and chemical breakdown of complex organic remains with the help of decomposers. Okay, so here you have to remember one point known as detritus. It's a term, detritus, very very important. So if in exam it comes with detritus, you should know that detritus means this is the organic remains. Okay, this is the organic remains, especially like dead plant parts, or you can say animal remains or excreta. They all form the detritus. So remember that in a terrestrial ecosystem, where there's a terrestrial part out there, the upper layer of soil, that is the main site of decomposition. Okay, this much you should know about decomposition. Now moving on to the process involved in decomposition. Okay, so let's talk about the process involved in decomposition. So what is the process? So number one, we have got the fragmentation process. Then number two, we have got the catabolism process. Number three, we have got the leaching. Number four, we have the humification. Okay. Number five, we have the mineralization. So I will just give a quick recap of what it is. So fragmentation of detritus means, see the name itself, fragment. So that means what? When we are feeding off the large pieces, okay, large pieces to the detrivorous, and after the feeding, what is left with us? The smaller fragments. Okay, that means the breakdown of the large pieces of detritus into the smaller fragments. That is called your fragmentation. Okay, so now next is catabolism. Catabolism means what? That the decomposers out here, this bacteria and fungi, since we're talking about decomposition process, so decomposers, what they do, they will excrete some digestive enzymes. Okay, so they will excrete some digestive enzymes upon this detritus. So what will happen? This will change this insoluble complex organic matters into simple and soluble organic compounds. That is called catabolism. Leaching means out here that leaching means to passing off. Okay, to passing to, now when these substances which are produced, okay, during decomposition, if they are soluble, what will happen? They will pass to through the soil to the deeper parts. Okay, so this is known as leaching. You can say passing off or passage of the soluble substances to deeper layer of soil. Okay, with the help of water. Now we come to the humification. Humification means what? See, you have heard about humus. Humus is what? It's a dark colored amorphous organic matter which is rich in lignin and cellulose. So humification means the process of formation of humus, very very important, which is a dark colored amorphous organic matter. I told you it's rich in lignin and cellulose. Remember this. Okay. So this humus, it will get decomposed slowly, and as soon as it gets decomposed slowly, gradually, it will release the nutrients also in the soil, thus making the soil fertile. That's why we say that if humus is present, the soil is fertile, because what will happen, as gradually it will be getting decomposed, they will release some nutrients. Okay, at the end we have got the mineralization. What does it means? It means that when both non-minerals, okay, non-minerals and inorganic minerals, okay, so when non-minerals and inorganic minerals, when they are releasing, okay, from the organic matter, that's called mineralization. So this is a very very slow process. Remember that it's a very very slow process. Okay, now this is done. Now let's move on to our next part known as the energy flow, which is very very important for your exam. Okay, energy flow. So energy flow means what? You know, we have told you that Okay, in an ecosystem, what happens? You see that one organism is fed on by or eaten by other organisms. So you can see there's a chain occurring. Okay, so what's happening? There's a process occurring in ecosystem. Okay, so during the process, energy is being transferred in the form of food. Okay, so this transfer of energy is known as energy flow. Okay, this energy flow, what's happening is that this energy flow has got two laws of thermodynamics. It follows two laws of thermodynamics, very, very important. So, first law, we know that energy can be transferred as well as transformed, but it cannot be created or destroyed. First law. Okay, very, very important. Remember the laws of energy flow. Okay, first law is that energy can be transferred as well as transformed, but neither created nor destroyed. And number two, we have got out here that every activity involving energy transformation is accompanied by dissipation of energy. So these two laws you have to remember, very, very important again question for exam, energy flow, laws that are governing this flow of energy. So remember that. Okay, now moving on to the characteristics of this energy flow. So I've told you the both the laws. I've told you number one, laws, very important, remember this. Number two, we have got the type of energy flow. Remember always this energy flow is unidirectional. Okay, it is unidirectional. So that means what? It always flows in a one way. Now that's the key. Like in this part we have got out here, we have got the producers, and then we have got the herbivores, and then we have got the carnivorous. This can never go in the other direction. Okay, it will always go in one single direction. Okay, one way. This is known as unidirectional flow of energy flow. Fine. Now, another thing is that when herbivores, when they take in food, that time a lot of wastage of food occurs. Okay, so energy is out here used for what? For digestion of food. Okay, so this is some this is not so important, remember this. Okay, one more thing I'll tell you about is that um, this is one term known as PAR. I told you in my class of ecosystem. So what is happening that whatever solar energy is falling on the earth, okay, so in that 1 to 5% of that incident solar energy, okay, this is being captured by the photosynthetic organisms in the synthesis of organic matter, or you can say cross primary productivity. Okay, so here this is also not so, it's okay, you can remember this thing, but what I want to tell you in this part energy flow is about the 10 percentage law, very, very important. So in this energy flow you cannot miss the laws of energy flow. Number one, number two is the characteristics, that it's unidirectional. Number three is that the 10% law, which is very, very important. Okay, so what is 10% law? So let's talk about 10% law. Okay, so 10% law means out here. This was given by, proposed by Raymond Linman in 1992. So according to this law, what is happening is that only 10% of the energy available at one trophic level. Suppose this is the trophic level. Okay, I've drawn a pyramid out here. So that means from one level, when the energy is flowing from one level to the other level, what is happening? Only 10% of the energy available at one trophic level passes to the next trophic level, and 90%, remember, 10% is pass and 90% is lost. So this is the 10% law. Understood? So remember this law is very, very important for your exam. Now just giving you an example. Suppose producers out here, it is 1000 kilocalorie. Then herbivores will, what will herbivores be? It will be 100 kilocalorie. Okay. And then carnivores will be 10 kilocalorie. And then we have got the, you can say the top carnivores. Okay. So top carnivores, they will have 1 kilocalorie. So this is the 10% law. Now again coming to the next part, that is called the food chain and food web. Another very important thing. So about pyramids, we'll talk about it at the end. So in food chain, what is the food chain? The food chain means it's an interaction between living organisms of an ecosystem. Okay. So there's a repeated occurring out here. So I'll just give a heading, food chain. Okay. So what's happening out here? There's a repeated eating occurring. That means one group will eat the other group. So one group will eat the other group. Okay. So this is continuously happening among the organisms. Like basic example we can take out here. Suppose we talk about just take example of some in the soil we have got some worms and all. They are eaten by some organisms. Okay, okay, forget this one. Let's talk about the grass part. So grass is taken up by the herbivorous. Okay, like we have got goat out here. Okay, goat or cow, and then goat and cow are eaten by the carnivorous. Like we can talk about this lion, or we can talk about other organisms like your, you know, we've got tiger out here. So also we can have got the humans, they also eat this, right? And then we have top carnivores, which are eaten by, which are eating this thing that is the, we can say vulture out here, eagle vulture. So there's a food chain forming, okay? So that means one organism is eaten by the another organism. And this food chain is always straight. And it goes in a straight line this way, okay? It will not go in a zigzag way. It will always go in a straight line, okay? So this is the characteristics of food chain. Now let's talk about the types of food chain. There are again two types out here. One is the detritus food chain, DFC, and then we have got number two is the grazing food chain, GFC. Okay, so detritus means what? It begins with the dead organic matter. Okay, so who eats a dead organic matter? The decomposers. Okay, they will eat it. So after that, the uh, energy is passed on to the next group. Okay, so now this detritus or this kind decomposers in this one, okay, they are eaten by the next group, or you can say small carnivores. Okay, these small carnivores are eaten by the large carnivores, and this continues. So this one example we can take about an earthworm, okay? The earthworm cycle. What is happening out here? The detritus are eaten by the earthworm, and the earthworm is eaten by the sparrow, and sparrow is eaten by falcon. Okay? So this is an example of a detritus food chain. Now coming to the GFC. In GFC, what do we have? This is a very, very common food chain in our ecosystem because it's also called as the predator food chain. That means what? It contains of producers, then we have got consumers, and then we have got the decomposers. Okay, so just example out here we can take out here producers. We can take phytoplanktons. Okay, phytoplanktons, they are eaten by the zooplanktons. Then we have got the, so this is the producers. Okay, this is the primary consumers, the zooplanktons, and then they're eaten up by the secondary consumers known as the, like any aquatic insects or aquatic organisms. So they are the primary. Uh, these are the primary. This is the secondary consumers. Okay. Now this is the This is the carnivorous. Okay. This is the primary carnivorous. Remember this. This was the herbivorous. This was the herbivorous. This is the primary carnivorous. Then we will move on to secondary carnivorous. Also example like fish. So this is the tertiary one. Its example is fish. Okay. This fish is eaten by the large fish. Or you can say top carnivorous. So this is the example of a grazing food. Not grazing one, sorry. This is the detritus food chain. Okay. So grazing food chain is very easy one out here. Okay. Okay. Now let's move on to the food web. Again, very important part. So food web out here, we know food web when many food chains they are connecting. Okay. When many food chains are connecting together, then they form the food web. Okay. You can see they are forming, they are connecting. Okay. So when many food chains are forming a network, they are interconnecting among each other at various trophic levels. Okay. To form a number of feeding connections among the different organisms in a biotic community. It's known as the food web. The network is known as this food web. Fine. So this much you should remember for food web. Now, very very important, we have the ecological pyramids. This one you should not miss for your exam. So this is what? This is a graphical representation. Remember, pyramid is a graphical representation of the relationship between individuals in various trophic levels of a food chain. Okay, so remember, gradually, like normally, the food producers are always at the base. Okay, and then after that, what is happening? The carnivores are at the top. In the top, we have got the carnivores. Okay, the top carnivores you can say. Okay, top carnivores. So this is a basic diagram of a basic representation of a ecological pyramid. So this was developed by Charles Elton in 1927, and therefore they are also known as Eltonian Eltonian pyramids. Okay, remember this. So again, ecological pyramid can have three shapes. It can be upright, it can be inverted, or it can be spindle shaped. Fine. Now there are three types of ecological pyramids. One is pyramid of number. Very very important. Pyramid of number means what? When we represent the number of individual organisms in a particular area, okay, of various trophic levels. Just like example of grassland ecosystem. So out here what's happening? Out here the pyramid of number is there and it is always upright in shape. So remember, pyramid of number is always upright. Okay. So there are three types out here. Pyramid of number. Okay, so number one is pyramid of number, is always upright in nature, and example is the grass ecosystem. Fine. Also, if it's also there in aquatic, also in pond system, also we have got here where the producers are the mainly they are the phytoplanktons. Okay, producers are phytoplanktons, and they are more in number. And then even here, this pyramid is upright. Okay, so remember in grassland ecosystem and also in the pond ecosystem, pyramid of number is always upright. PN. Okay, then number two we have got out here pyramid of biomass. So do I need to show you a diagram of pyramid of number? So you can see uh, this is the one which I showed in top out here. Okay, this is the pyramid of number. Okay, so this is a grassland ecosystem. So this is the primary producer PP. This is the primary consumer. This is secondary consumer. This is the tertiary consumer. Okay, this is an example of the pyramid of numbers in grassland ecosystem. Then we have got number two, pyramid of biomass. So pyramid of biomass out here, what's happening? This pyramid of biomass is also like just like an upright structure. It is upright structure. Okay. Now, what is happening out here? There is a progressive reduction of biomass in herbivorous and in carnivorous and in secondary carnivorous. So we can say out of the 10 to 20% of biomass is transferred from the lower traffic level to a higher traffic level, and rest is consumed in providing energy for giving heat. Okay. So in grassland and forest, so what's happening out here? Let's see. So in grassland, okay, in grassland and in forest. So out here what's happening that there is a gradual decrease in biomass. As and as the levels are increasing, the biomass is decreasing. So as biomass is decreasing, what's happening at successive levels, this pyramid is becoming upright in nature. Okay. So remember this, that in pyramid of biomass PB, it is upright in nature if you talk about grassland and forest. Okay. Now, if you talk about a pond, this was for the grassland and forest. If you talk about pond, in a pond ecosystem, the producers are very small organisms. So their biomass is very less, and then there is an increase in the pyramid on the top of that because the primary consumers are more than the primary producers. So this is forming an inverted shape. Okay, so pyramid of biomass in a pond ecosystem, it is inverted in shape. Okay, number three will come to the pyramid of energy, PE. Number three. Okay, so PE, remember, this is always upright. Always upright. Okay, energy out here, that means what? There is a gradually a decrease of energy at successive trophic levels from producers to various consumers. Now, what are the limitations of this ecological pyramids? So number is that ecological pyramids, they think that the food chains are very very simple, although um, like food chains are not so simple. Okay, and you cannot see food chains in nature. They're not always seen. So you can see mostly food webs are present in the nature. Okay, and in ecological pyramids there is no place for detritivores and decomposers, which are also playing a very important role in ecosystem. So these a limitation is there. Also in ecological pyramids, we cannot show any food web. So these three are there in the limitations of ecological pyramids. Also, one more thing is that sometimes you will see one same species, single species, they are operating in two or more trophic levels. So there's again limitations of ecological pyramids. So this is all in there about ecological pyramids. Okay. So I hope you have liked today's fast revision of ecosystem. So if you have any doubt, do comment below, and do share it with your friends, and also do subscribe to my channel for more such videos. I'll be keeping on posting now more videos so that you can quickly revise your for your exam. Thank you so much.